Topic we are going to discuss today is understanding ionic bonds. So basically, what is ionic bond? Ionic bonds are formed between two ions carrying opposite charges, resulting in a strong electrostatic interaction. These bonds are essential in determining the structure of various compounds and elements, significantly influencing their unique physical and chemical properties. Understanding ionic bonding is crucial for studying chemical interactions and material behaviors. So, for example, we have different ions like Na and Cl. Na carries positive charge and Cl carries negative charge. So, they both attract each other and form a bond, which is an ionic bond. Definition of ionic bond. First of all, according to the nature of ionic bond. Ionic bond occurs through the transfer of electrons from one atom to another, typically between a metal and a non-metal. So sodium is a metal and chlorine is a non-metal. So they are going to make a bond, which is an ionic bond. Second is electronegativity difference. Significant difference is in electronegativity, greater than 1.7 between the two atoms is necessary for ionic bonding. Formation of lattice. Ionic compounds often form crystal lattice structures, maximizing electrostatic attraction and stability. Now we have the examples of ionic bond. First is sodium chloride. Sodium chloride is commonly known as a table salt. It's a classic example of ionic bonding. And second is magnesium oxide, formed when magnesium transfers 2 electrons to oxygen. The resulting Mg2 plus and O2 negative ions create a strong ionic bond, demonstrating high melting and boiling points. Then calcium fluoride. Calcium donates 2 electrons to fluorine atoms, forming calcium ions and 2 fluoride ions, which are held together by strong ionic forces. Then we have some properties of ionic compounds. First is high melting and boiling points. Because there is a strong interaction between these and the ionic compound is very strong, so it's very difficult to melt them or to boil them. So they have high melting and boiling points. Similarly, if we talk about solubility in water, so ionic compounds are soluble in water due to ability of polar water molecules to stabilize ion. So they are soluble in water, like table salt is soluble in water. Electrical conductivity, so they conduct electricity when they are in molten form or dissolved in water, and in the solid state they are non-conductor of electricity. Okay, when we are going to compare ionic with the covalent, so ionic is basically the complete transference of an electron, while covalent is simply a sharing of electron pairs. If we talk about the bond strength, so ionic bonds are generally stronger and covalent bonds are weaker as compared to ionic bonds. Property variation, so ionic compounds form crystalline solids, while covalent vary in state and melting point. Applications. So we have the biological significance. We are using the ionic compounds in biological systems, in industries, especially in making fertilizers, and in salt formation for the food preservation and seasoning. Now we are going to take a final overview of ionic compounds. So first, they are made from the electron transference. Second, they have high melting and boiling points and solubility in water, plus the electrical conductivity in solution and in molten state. Third is chemical importance. They are very important in chemistry and material interactions. Thank you so much for listening.